好吧，我们开始吧。Okay, so today Dr. John will not come here because he is sick a few days ago and he's still recovering in a hospital. So today I will take this course. And today we don't have new progress today. Okay, so today we will check the answer of midterm exam. So first we see the paper. Okay, problem one. Just answer true or false. You don't need to explain the reason is true or false. Okay, so for problem 1 and problem A, a TND attached to a system may make a system unstable. So the answer is false. And it is because TND has a damping, and damping will take out the energy gradually. So the system will not become unstable when it attached to a TND. And for problem B, frequency response function of a system is computed from its transient response. Also, it's false because the frequency response function is computed from its steady state response. Okay, I think it's no problem, right? Oh, if you have any questions, you can just raise your hand. Okay. And for problem C, discrete time model of a mechanic system with a given sample time interval is unique. The answer is true because when we set the sample time interval, and we have a unique discrete time model. Okay. Any problem? Yeah.
Time model 是变成 ABCD 还是？
Would you mind to say English because there is a broad student.
The discrete time model means the system about ABCD matrix. So how can C and D be unique? Because we can.
Okay, I know what you mean. You mean if we have different sensor, the C and D matrix were not unique.
Yes.
Okay, I keep this to the next class, and we can ask Dr. Zhang to discuss about this. Okay.
Okay.
Yeah, I think so. So, any else problem? Okay, so problem D, the system is asymptotically stable if the absolute value of each eigenvalues of discrete time model is outside a unit cycle. So the answer is false because if the eigenvalue is outside of the unit cycle, it means the system will not converge. You know what I mean? Because it means that the damping ratio is not little than 1. So the system the system response will become larger and larger. It will not decay. Okay. Any problem? Okay, so next problem. Eigenvalues of a mass matrix for a mechanical system are always positive. Okay, it's true. Because mass matrix we can check it, it is positive definite, and the eigenvalue, if the mass matrix is positive definite, then the eigenvalues will all larger than 0. Okay, let's go to problem 2. So for problem 2, the first question, the virtual passive controller design is model independent. The answer is true. Any question? To think about model independent, it is because no matter what virtual passive controller you attach to a system, this system will not become unstable. So you don't need to care about what system it is, because you will not let this system become unstable. So all you need to consider is the performance. So that's why we call it model independent. Okay, any problem? Okay, so next, go to next. If all the system metrics are positive definite, then the system is asymptotically stable. Okay, it's true. Then the question C. The observer matrix A, B, C, D, and G for a given system are unique. The answer is false. Any questions about this? We determine the G depends on A bar. If you studied it, you can know what is A bar. A bar is A plus GC. Okay, so to determine the G, it depends on A bars times P. Times P. Power P equals to 0. Then we can determine the G. So if the P is not given, so we can say this system are unique. We can say the G is unique because we don't give a P. Okay. So for next, a finite difference model doesn't require any state estimation. Okay. If you see the finite difference model, and you can know there are no x in the equation, right? So it means we don't require any state estimation in the finite difference model. That's true. And the next question, E. Conversion of a discrete time model to its corresponding continuous time model is unique. The answer is false. Any problems about this? No? Okay, so let's move on to problem 3. So for problem 3, question A, a square matrix has no column or row null subspace. The answer is false. Because you can't say a square matrix is full rank, right? So which means it will have some null space, null column space, null row space. And question B, a rectangular matrix has a column or row null space. The answer is true. Yes. Just if you write homework 7, you can know it is true. Because when you do SVD for a matrix, then you can find some column null space or row null space. And for problem C, a positive definite matrix has no column or row null space. The answer is true. Any problems about this?
What?
Okay. Because if you say a matrix is positive definite, you can also say this matrix has no zero eigenvalue, and all the eigenvalues larger than 0. So which means there's no column or row null space, right? Okay, just like you do SVD for rectangular matrix, and you can find a null space when there is a single value is 0. Yeah, understand? Okay, so for question D, a 4-rank square matrix has no column or row null space. Okay, the answer is true. How? So for question E, single values of a real matrix are always larger or equal to 0. Okay, this is probability of SVD, right? So the answer is true. Any other problems about problem 3? No? Okay, so next move on to problem 4. For the first problem A, form the matrix just like the matrix below. Yeah, you just substitute A and identity matrix and B matrix into this question, right? And you can form this matrix. I think this is easy. And problem B, find its column null space in terms of, oh, there's some mistake. This is lambda, okay. So just observe the gamma matrix, okay, capital gamma, and you can see the null space is empty because all these column vector can describe the 2-dimension space, right? So the column null space is empty. And also, if you want to do some mathematics, you can just do like this step, and you can find the null space is 0. And if your answer is empty, is also correct. Okay. And the question C, find its row null space in terms of lambda. Okay, for me to doing this problem, I just find the cross product of these two row vector. Do you understand? Because the row space means that vector is orthogonal to both these two row vector, right? So you just do cross product of this row vector, and you can find the null space is 1 lambda and 1 plus lambda squared. Any problems? Should I do this on arrival? No? Okay. So let's move on to problem 5. Okay, first question is the closed loop system asymptotically stable and Why? Okay, the answer is yes, because you can check all these three metrics. Okay, and to check it, all these three metrics is positive definite. And I think I can show you. Hold on a minute. So for the first matrix, you can okay, the positive definite, we use this. No matter what vector this is, then we need to check this equation, matrix equation, is larger than 0. Okay, so finally you can find the answer. Oh, okay, you can find the answer. This matrix equation is like this. Okay, so this is larger than 0, and larger than 0, larger than 0. So this is larger than 0. So you can check, and this is positive definite. Okay, so all these three equations, all these three metrics, you can check it is positive definite. So we can say this system is asymptotically stable. Okay. And for the next questions, oh, okay, we need to find out the controller. Oh, check that. Okay, first we need to find out the control force U and the controller dynamic equations. And oh, where is the original system? Okay, I write it on the right ball. Wait a minute. Okay. So to find the u, you can see this u, and this is the original system, right? And this is a closed loop system. So we just expand the first row, and you can get the u. Okay, so the u is equal to w1 double dot. And it's minus wc double dot. Okay, any problems? You just expand the first row of the closed loop system and then compare with the original system. Then you can get the u. And to find the controller dynamic equation, you can expand the third row of this matrix equation. Then you can get w1 double dot plus wc double dot plus wc dot. This is 0.1 plus wc equals to 0. And to take this term here, then we get the controller dynamic equation, right? Okay. Any problems? So for this closed loop system, we need to calculate this term because our u is equal to this, and this is measurement, right? And we need to calculate this to control the system. So to calculate wc double dot, we need to use this equation. Then we can control this system. Okay. Oh. Okay, so any problems about problem 4 or problem 5? Okay, so next move on to problem 6, which is the last one. And okay. So for the first question, we need to find the first order equation of motion for x. Okay, so let's rewrite the equations on on the problem. So we can first write a equation like this. Okay, any problems about this? And so we need to check the system is this, and the input of the system is this, right? So first question is the first order of x. So we need to write this equation into matrix equation, and let it become the first order equation. So it will become okay. If we assume this is w, then this is w dot. So we call it first order equation. And so this is 0, 1, and minus. Okay. It's 0 and okay. Any problems? So this is sorry.
I don't know. There's this way I did it. I was thinking if maybe it's right. I combined the input. I have the input inside in the system also. Like I have eta x dot minus eta y dot. Now I have my first order equation now becomes x dot y dot. I don't know how.
Oh, you mean you combine these two things?
Yes.
You need to first figure out this is the input and this is system state. So you can combine these two terms together, okay? Because this is system state and this is input, okay? So for the first order matrix equation, you need to write this. This is a system first order equation. Any comments?
I don't know, but we have the ICT and the Y in the given equation. Do you understand what I mean? In the given equation, we have the YDT, the SDT, and the YDT.
Oh, but you need to read the problem, right? Because the problem say the Y is a wave entity active, so which comes from the rough road, so you can understand its input. Yep.
Because the y has given the equation, so we don't have to solve the y. So the y doesn't need to compute the
Oh. For this case, we need to consider the input, okay? Because the question is not just expand. The question is not say we need to write the motion of x without input force. So we need to calculate it.
because we don't just don't know because the y is known. So we don't
No, the y is given.
the y is known.
Uh-huh.
Given, so don't need to solve.
Yeah. Yes. So okay. Okay, so for the next question is to compute. Okay, to compute natural frequency and the damping ratio. Okay, so for the natural frequency, we can write, it's very easy. So it's just square root k over n. And then to substitute the value of k and n, you can know the answer is 4 times pi. Okay? And then we calculate the damping ratio. So it is equal to zeta over 2n omega n. Okay, so do the same method to substitute the value in, so we can get the then mirror 0.01. Any problems? Okay, so next question is to calculate the eigenvalues of the system. Okay, so to calculate the eigenvalue, so first we assumed x is equal to, okay, because the eigenvalue is relational to the system. Okay, it's now there is no relation between the eigenvalue and the input, right? So we can assume the input equals to 0. Then we calculate the eigenvalue. So x equal to, we assume x equal to lambda t. Sorry. Then lambda is eigenvalue. So substitute into the system equation. Then we can get okay. So finally we can get lambda is equal to right? Oh, sorry. Yeah. Okay, so it is equal to okay. Any questions? No. So for the next questions, to solve for x of t with 0 initial condition, it will take very long. So I think the final question is testing about engineering, mathematics, and I think you learned it before. So you get first you have two eigenvalue, and which is equal to right. So we can get a homogeneous solution x of h is equal to c1 exponential lambda 1t plus c2 exponential lambda 2t. Okay, this is a homogeneous solution. So first we assume x of t is equal to the homogeneous solution plus the particular solution, right? Then the next step we need to solve the, we have solved this. This is this, okay. And the next step we need to solve the particular solution. So to calculate the particular solution, because we know y is equal to so we can assume the particular solution is equal to a sine 4 pi t plus b sine 4 pi t, and okay, so this is we assume the particular solution is equal to this, and so the next step we because I haven't get the answer of this question because I haven't done it. Okay, so now I just tell you the step of this question, how to calculate the x of t. Okay, so first we need to solve a and b, and then we get this term, but we still have two unknown because c1 and c2 is still unknown. So okay, first we talk about how to calculate a and b. So we need to substitute x particular solution into this, and you can compare the coefficient of these two equations, and to find out a and b. Is it okay? You just substitute this into this equation. Okay. And you can get a and b. And the next step, you find out this, and you substitute this all these terms into this equation again, and you use the initial condition t equals to 0 and the x of t equals to 0.
But we are given only s of t equals to 0 because that is the reason why I didn't even go for it. So
it's
we are already giving t equals to 0.
Yeah, the question say solve for x of t with 0 initial condition.
0 initial condition of
Yeah.
0 as an s of t equals to 0, not t equals to 0.
Sorry.
It is.
Is x of 0 equals to 0?
No, the question said s is 0 initial condition.
Yeah.
That is when s of t is equal to 0, not when t is equal to 0. Not when the time, because when I read it, I got a little bit confused. I was like, okay, I think it's S of t. That was why I stopped in homogeneous.
Oh,
He said when initial condition, which is S of t equals to 0, it's a different thing. S of t equals to 0 and S of 0 equals to 0. So I say who here now?
with
I don't know if somebody is
with
understanding
zero
what
initial condition means x of 0 equals to 0. Yes, that's true. Okay. So when you get when you get a particular solution, and you can use x of 0 and the xh of 0 and xp of 0 to get the C1 and C2. Is that okay?
Yeah, it's not okay. Seriously, it's not okay because I got
Yes.
confused in that hall. I was thinking we aren't given at what value of t. We aren't given at what time interval, right? I was like, okay, it's maybe at s of t equals to 0. Then I saw for s of t, which we cannot use to find the two constants C1 and C2. So I stopped at the initial condition anyway because I was thinking it's just s of t equals to 0, not x of 0 equals to 0. Because it said at initial condition.
Yeah.
Initial condition of time interval, you can take initial condition to be 2. You can say t to be 2 is an initial condition. You can say t to be 10 is an initial condition. So it's not defined. The only thing that was defined is the initial condition of the function,
I know
which
what
is
you
s
say.
of t. So that was why I said s of t equals to 0. And I saw s of t equals to 0, which you cannot use to find the two constants. I don't know whether you get what I'm saying. But anyway, I've read it from the beginning, so that's why I don't want to.
I think keep these questions next week. Okay. And to ask Dr. John, okay? Is that okay? Yeah.
I've read the questions of the beginning.
Okay, so any else problems about how to maintain Zen? Any questions? Okay. So
we know our grade. It will make us feel good if we know our grade. For the midterm and for the homework, so we know where we are.
Yeah. For the grading, I haven't done yet. For the midterm Zen, but I have finished some homework. So I will show you. I will show it on the website. Few days, I think. In few days, yeah. So, any else? Any other questions? Okay, so I think this is the end. Okay, so thank you so much.